morning. Seventh grade math. Welcome to Tuesday, November the 10th, 2020. We're going to be starting another lesson today. Constant rates of change. Now, you'll find different rates of change. Obviously, our growth as human beings physically won't be constant. In other words, the amount that I grow depends upon a lot of factors. That's not going to be constant. So we're going to talk about things that are constant. Right now we're at page 123 in your text. If you could open to that, please. So the first example here, discovering proportional relationships. It takes a giant tortoise 3 seconds to travel 10.5 inches. The diagram shows the rate at which the tortoise moves. Use the diagram to determine if the tortoise is moving at a steady pace. Well, in the first second, 3.5 inches. Second, 3.5 inches. Third second, I'm sure it's going to be 3.5. What unit rate is represented in the diagram? Inches per second. Okay. So now they're asking us to fill in the table. 1 second, 3.5. 2 seconds, 7. 3 seconds, it's already done for us. 10.5. 4 seconds, 14 inches. 5 seconds, 17.5 inches. Now it's asking us to look at the ratios here and see if they're proportional. For each column of the table, write a rate that compares the distance and time. Put distance as the numerator and time as the denominator. So distance is the numerator, 3.5. Time as the denominator. 3.5 divided by 1 is 3.5. 7 divided by 2 is 3.5. 10.5 divided by 3 is 3.5. And 14 divided by 4 is 3.5. 17.5 divided by 5 is 3.5. Okay, now I'm going to go back up here to the first question. Use the diagram to determine if the tortoise is moving at a steady pace. Explain. Yes, the tortoise is moving spell correctly, knucklehead, at a rate of 3.5 inches per second. Okay, what do you know about the decimal forms of the rate? Each decimal form is 1/2 or 0.5 hundredths? Conjecture. How do you think the distance the tortoise travels is related to time? Since the tortoise is moving at a constant speed, the rates are measurable. Okay, let's go on to the next page. Reflect. Suppose the tortoise travels for 12 seconds. Explain how you could find the distance to travel tortoise travels. Multiply 12 times 3.5, and that's going to equal, here you go, 12 times 3 is 36. Half of 36 is 42. I know many of you are out there saying, oh, I'm not sure that's true. Well, let's find out if that's true. I'll bring in my backup. 12 3.5. How about that? 42 inches. How would you describe the rate of speed at which the tortoise travels? 3.5 inches per second. Okay. A proportion is a ratio. A proportion is a statement that rates that two rates or ratios are equivalent. For example, 6 miles in 2 hours is 3 miles per hour, or 2 to 4 is the same as 1 over 2. Okay. A rate of change is a rate that describes how one quantity changes in relation to another quantity. A proportional relationship between two quantities is one in which the rate of change is constant, or one in which the ratio of one quantity to another is constant. Proportional relationships are often described using words such as per, or, for, each. For example, the rate $1.25 per pound could be described as $1.25 per pound or $1.25 for each pound. Okay. Good old Callie here earns money for dog sitting. Based on the table is the relationship between what Callie earns and the number of days, a proportional relationship. So let's look here. 1 day, she got $16. 2 days, $32. 3 days, $48. 4 days, $64. 5 days, $80. So yes, they are proportional. The constant rate of change is $16 per day. Your turn. The table shows the distance Allison drove in 1 day of her vacation. The relationship between the distance and the time is the relationship between the distance and time a proportional relationship. Did she drive at a constant speed? Explain. Well, let's look here. 65 miles in an hour, 120 miles in 2 hours. Whoa, 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 whoa. What do you think? If it was proportional, in 2 hours, she should have traveled 130 miles. Let me check this out. I think they're way off here. 65 divided by 1. Okay. 120 divided by 2. Oh, no. 60. Look at that. 195 divided by 3. Whoops. 195 divided by 3 is 65. Oh, look at that. So it's not proportional. Not a proportional relationship. Now you have to understand that when you're driving from point A to point B, unless there are absolutely no cars on the road, you're the only car, go figure that's going to happen, you're probably not going to travel at a measurable or constant rate. You're probably not going to. At the end of your journey, you may have an average rate, but not a constant rate. Okay? Writing an equation for a proportional relationship. Is there a proportional relationship between, if there is a proportional relationship between x and y, you can describe that relationship using the equation y equals kx. The variable k is called the constant of proportionality. Constant of proportionality. And it represents the constant rate of change or constant ratio between x and y. The value of k is represented by the equation k equals y over x. So let's look at the second example. 2 pounds of the cashew shown cost $19. 8 pounds costs $76. Show that the relationship between the number of pounds of cashews and the cost is a proportional relationship. Then write an equation for the relationship. Describe the proportional relationship in words. Okay. Let's take out calculator here. 19 divided by 2 is 9.5. 28.5 divided by 3 is 9.5. 76 divided by 8 is 9.5. Okay. So it is a constant relationship. So the pounds for 2 pounds cost $19, 3 pounds $28.50, 3 pounds, or excuse me, 8 pounds $76. Write an equation. To write an equation, first tell what the variables represent. X is going to represent the number of pounds in cashews. X. Let Y represent the cost in dollars. Here's Y. Use the decimal form of the constant rate of change as the constant of proportionality. The equation for the relationship is Y equals 9.5x. I'm going to stop this video here. I'm not going to give you a code word until the final video this morning. So that we can meet at 9:30 for the Zoom.